All right. This is one of my favorite sections, section 11.6. I know we're skipping around. What we're looking at is arc length and the area of a sector. So I'll explain what all of that is. So the first thing is, what is a sector? A sector, I think of pizza slice. So this is a sector, and you can see pizza slices are basically sectors. And you get them when you draw two radii into the arc of a circle. And so this little triangle pizza slice thing is called a sector. We're going to find the area of those sectors, and we're going to find the length of this part of the circumference AB. To start, we're going to do a little exploration. So here's what we're going to draw. So draw this. We have three columns here. We're going to draw a circle in this column, and let's draw a straight line through the radius. So the angle for this straight line is 180 degrees. Okay, so angle of 180. What fraction of the circle does this cut off? Well, half, right? Half the circle. So this is 1/2 the circle. Okay. Now for the last column, what is the angle, in our case 180, divided by 360? So 180 divided by 360. What does that reduce to? Well, 180 is half of 360, so that's 1/2. Okay, maybe you see where this is going. We're going to draw another circle, and this time we're going to draw a right angle, so a 90-degree angle. So the angle in this one was 180, this one is a 90-degree angle. What fraction of the circle does that look like? Well, to me, that's a quarter of the circle. So we have 1/4 of the circle. Visually, you can see that. Now, what's the angle divided by 360? 90 divided by 360, what do you know? 90 is 1/4 of 360. So there seems to be a connection between what fraction of the circle we see visually and how we can calculate that fraction, taking the central angle and dividing it by 360. So we'll do one or two more. Well, here's the idea. I'm going to draw a pizza slice, a sector, that looks like that. At the moment, it's hard for you to tell me what fraction of the circle that is just by eyeballing it. So then I tell you, okay, this is an angle of 60 degrees. It's still hard to tell just by looking what fraction of the circle it is. So we put question mark. But this column seems to give us a way to actually calculate that. It seems to be whatever the angle is over 360, sort of the fraction of the angle of the whole circle. And 60 over 360, that's 1/6. So now we know this is 1/6 of the circle. Okay, that's the introduction. So now we're going to actually answer some questions about length and area. So the diameter of this circle is 10. So then the radius is 5. So here's the center, the radius is 5. That's going to be important. I want to know, what is the length of arc ACB? Now, hold on a second. This is a key moment where I'm asking a different question. So far, every time we've looked at arcs, I've asked the degree measure, 180 degrees, right? The arc is 180 degrees. Now, we're not talking about degree measure. We're actually talking about length. So if I were to measure with a string how long that arc is, how many inches or feet would it be? Well, this relates very closely to circumference. So what's the circumference of a circle? We need to review that. Circumference is 2 pi r, and the r is 5. So the circumference is 10 pi. Let's put some units on here just because I think it'll help. So 10 meters. So the circumference is 10 pi meters. So the length all the way around is 10 pi. So then how long is this part? Well, it's half the circle. It's half the circumference. So it should be 1/2 of the circumference, which is 10 pi. So only 5 pi, right? So if it's half the circle, it's half the circumference. Let's do another one with a nice angle where we can kind of visualize it, and then we'll get to formulas. So this is a 90-degree angle, quarter of the circle, and the radius is 6. We want to know how long this is. Not just that it's 90 degrees, we know it's 90, but how long? Well, it's a quarter of the entire circumference, right? If I had 4 copies of it, 1, 2, 3, 4, I'd have the whole circumference. So I want to take a quarter of the circumference. So the circumference is 2 pi times r, which is 6, is 12 pi. So I want a quarter of 12 pi, which is 3 pi. And lastly, now we get towards our formula. If we have a 60-degree angle and a radius of 12 centimeters, how long is this? It's 60 degrees, but how long is it? We need to know, it's hard to eyeball what percent or what fraction that arc length is of the total circumference. But we have a way of calculating it. So the fraction is given by, before we were eyeballing it, that looks like a quarter, that looks like a half. It was this column. We take the angle and we divide it by 360. So we take, the fraction is 60 divided by 360, which is, let's just get the fraction first, 1/6. So this is 1/6 of the circumference. 1/6 of the circumference. And the circumference is 2 pi r, or 2 pi 12, is 24 pi. So we want 1/6 of 24 pi. 24 divided by 6 is 4 pi centimeters. Hope that makes sense. What we're doing is we're using regular circumference, like we did in section 11.5, and taking it one step further by only finding a fraction of it. So what do you think is going to come next? Well, we just did fractions of the circumference. Now we're going to do fractions of the area. This is going to be very, very similar because the fraction of the circle is the same idea. So if this is a 90-degree angle, and I think this one's easier to see, this is kind of what I did in the warm-up more visually with area. This sector, the area of this sector, looks to be a quarter of the circle. So it should be a quarter of the total area, right? There's 4 identical copies of that area, and we only want a quarter. So what we do is we take 1/4 of the area of the circle. The area of the circle, we need to review that formula, pi r squared. So we have 1/4 of pi, the radius is 6 squared. So 1/4 of 36 pi is 9 pi. So this is 9 pi. They're each 9 pi. Each quarter is 9 pi for a total of 36 pi. Let's do another one. So what fraction of the circle is this? It's 60 over 360 degrees of the circle. So this is the fraction. It is 1/6 of the circle. So if it's 1/6 of the circle, it's 1/6 of the area, which is, calculate that on the side, pi times 12 squared, or 144 pi centimeters squared. So we take 1/6 of 144 pi, which is 24 pi centimeters squared. So at this point, we're ready to state our general formula. If we want to find the length of the arc, length of an arc relates to circumference. So it should have the circumference formula in it. And then it's not the whole circumference, it's some fraction. And so the length is fraction of circumference. I need to write that. Fraction of circumference. So fraction times circumference. And the fraction is given by the angle over 360. We saw that in the exploration. The area formula is the same. Just replace the circumference formula with area. So it's the fraction times the area. So I would suggest you can pause, you can try this next one on your own, or if you need another walkthrough, I'll do it right now. and then we'll do one example of kind of the toughest questions I can ask. So, find the length of arc GE. So we want to know how long that is. Not just that it's 72 degrees, how long? Think circumference. So it'll be the circumference times the fraction of the circle. The fraction is 72 over 360. And a trick for reducing that fraction is actually to flip it. Do 360 divided by 72, and you find that that's 5, which means when you flip it back, 72 is 1/5 of 360. And so it's 1/5 of the circumference, 2 pi times r, which is 15. So it's 1/5 of 30 pi, which is 6 pi. Okay, now we get to the final example. And this is a classic example. There will be many questions like this on the homework, on the test, and so watch this one closely and come back to this one to review. So we're going to find the area of just the shaded region, the region that's bounded between the chord xy and the arc xy. How are we going to do this? This is not a familiar shape. What we're going to do is a very nice trick where we're going to find the area of the sector. I'm going to draw these on the side as well. So the area of this entire sector, so I'm going to draw it here. We have a sector that's YOX. This is a sector with a 90-degree angle. And then we're going to find the area of the triangle. Oops, drew it backwards. And we're going to subtract. So area of sector minus area of triangle. And that is going to give us the remaining shaded area. If we take the whole thing and we take away the triangle, we're left with the shaded. So that's exactly what we're going to do. Area of the sector. Well, go to our sector formula. It's angle divided by 360 times the area formula, pi r squared. The angle's 90, so 90 over 360 times pi 10 squared. So this is a fourth. So we have a fourth of 100 pi, or 25 pi. The area of a triangle, well, this is a right triangle, so the two legs are the base and the height. So 1/2 base height is 1/2 10 10, which is 50. So the area bounded in exact form would be 25 pi minus 50. And we can't combine that. Because of the pi, we can't do 25 minus 50. It's just 25 pi minus 50. And if we wanted an exact, a more approximate value, we could do 25 times pi, which is about 3.14, and then subtract 50. And if you do that, I'm just going to estimate, you're within the ballpark of about 30. So review that, make sure that makes sense, and then finish the packet.